Dr. T.V. Geeta, Professor, Department of Computer Science, College of Engineering, Guindy, Anna University. Her special interest, Artificial Intelligence and Natural Language. She has published more than 143 articles in national and international journals. She has guided around 7 PhD students. She has got Young Scientist Award from Government of Tamil Nadu in the year 2000, Chief Minister's Special Mention Award in the year 2002 and Woman of Excellence by Rotary Club in the year 2003.
Welcome to the UGC lecture series. In this lecture, we are going to talk about relational calculus, which is another formal model in which queries can be given. So, in relational calculus, we have two types of relational calculus, tuple relational calculus and domain relational calculus, in short called as tuple calculus and relational domain calculus. Now, let us look at what are the objectives of this lecture. We are going to understand the concept of relational calculus. We are going to look at some queries which are done using tuple relational calculus and other queries using domain relational calculus. Now, before I go to relational calculus in general, most of you up to this point would have studied about programming or specifying something to the system in a sequential manner. In this relational calculus, it does not do it in a sequential manner, it does it in a declarative manner. I will explain what is declarative manner in later. Now, relational calculus expression creates a new relation, whether it is relational algebra or relational calculus or whatever you have, the formal models of databases uses a relational uses a table, does some operation on the table and the output is again a table. So, the relational calculus similarly creates a new relation which is specified in terms of a variable that range over rows. If it ranges over rows, it is called as tuple relational calculus, and this is again similar to what SQL does, and or over columns which is called as domain relational calculus or DRC, and there is a query language called QBE, query by example, which is based on domain relational calculus. Now, relational calculus, so before we go further, we must know what is relational calculus. Simple subsets of first order predicate logic, and it uses some quantifiers. We will discuss what is quantifiers later to construct complex queries. So, basically it is a first order predicate logic, that means it has logical variables, it has logical operators, it has predicates which are true or false, and it has some quantifiers. So, the difference between the two calculus is in the level at which the variables are used, and if it is used at the level of tuples, if you remember, tuples are nothing but rows in the table, then or fields are nothing but columns in the table or attributes. If you use rows, it is called tuples, if you use attributes or columns, it is called domains. Now, before we go further, let us look at the difference between calculus and algebra. Now, Codd's reduction algorithm reduces expressions of calculus to algebra. So, whether you do it in calculus or whether you do it in algebra, you are able to express the same thing because they are considered to be equivalent. But then this is another thought process itself, this declarative methodology. So, we are looking at this. A language is said to be relationally complete if it is at least as powerful as the calculus. So, the expressiveness of the language is decided by its formal model. So, algebra is also relationally complete, and Quell, this is another language which is based on calculus and can be applied by implementing the algorithm and implementing the underlying algebra. So, basically relational completeness means the following. For theory it means it should be relational calculus or relational algebra. As I already told you, relational calculus can be in two forms, tuple or domain relational calculus, and then you have the relational model which is based on either of this. Most of the work we do on relational algebra, this is just to give you a feel of relational calculus. And in practice you have the memory management, the buffer management, the access methods, the relational operators, again based on one of these formal models, and the query optimization and execution. If you have all this together, then you call it as relational completeness. Now again let us go, in this lecture we are talking about relational calculus. So let us go back to relational calculus. The calculus is non-procedural, I have already told you, it is considered to be declarative and compared to relational algebra. Relational algebra is typically a procedural language. So what do you mean by declarative? I have not said that. That means there is no order on the operations, that is you do not specify an order of how to retrieve the query. You do not say first do the select, then insert, then do the deletion, then retrieve. You do not say that order. The order is not specified. So what actually is specified? It does not, as already told you, it does not give you a series of operations, but it just tells you in contrast relational algebra is based on the sequence of operations. Okay. So what does relational algebra calculus actually tell you? Relational algebra allows the user to specify the information needs, not in terms of operations. It does not tell you anything about what the operations are needed. The user does not have to specify that. The user has to just tell what is the information that he needs, what is his information need. So it is said that relational calculus is closer than relational algebra in formulating these queries. But whether you use relational calculus or relational algebra, both are logically equivalent. So CORD proposed a language called Alpha to implement this relational calculus. Remember, CORD is considered as the father of databases, and Quell, which is an early competitor to SQL, is based on this Alpha. So Quell is a query language, and domain calculus has been implemented by another query language called query by example, which you have already seen. The relational calculus building blocks are variables. So variables, if it is tuple relational calculus, they are tuples, are bound to tuples, and if it is domain relational calculus, the variables are bound to domain elements, that is the common column values, and you can have constants. So you can have variables depending on whether it is this or this, the variables are different, and then you have constants like 7, foo, whatever, and then you have comparison operations like equal to, not equal to, less than, greater than, etc. in most comparison operators. And then you also have logical connectors. Remember, this is a predicate logic expression. You have not, you have and, you have or, you have implies, and you have is a member of. So these are the logical connectives that are used in this predicate formation. And you have quantifiers. We will go into quantifiers in detail later, but basically a quantifier is given this P stands for a predicate, given a predicate containing x, P of x. If you say this is pronounced or specified as for all x, P of x, then it says that for all x, whatever the value of x, P of x must be true, and there this is specified like this is again a predicate, there exists an x for which P of x is true, at least one x for which P of x, it can be more than one, but you cannot specify that for everything this predicate is true. So this is a quantifier, just the notion of a quantifier. Now let us take an example like this. This is a sailor ID, this is a sailor name, and this is his rating, and this is the age of the sailor. So this is just a small table which we will use for the purpose of explaining relational calculus. So now let us take an example. Find all sailors with a rating above 7. So this is what we want to write. Okay. Now look at this. This says that this is a tuple relational calculus. It tells me that this is get me a set. Okay, I am specifying some condition for the set. What is this condition? This S, the set, must be a member of sailors, and that tuple's rating should be greater than 7. So we can specify this as from all find me the set of things that are tuples in the sailors relation, and whose rating field is greater than 7. Okay, this is what this particular tuple, it is not telling me select for me, retrieve, do intersection, it is not telling this. This is, please note, this is a predicate. Okay. So, for example, it says what will it do there? It is asking me to find all the sailors from this relation, that is what this specifies, and I want the rating to be greater than 7. So, I will get only 9, 8 and 10, I will not get this tuple. So, I will get only these 3 tuples, that is what this is stating. Now, I am going to talk about domain relational calculus in detail later on, but before we go further, let us just the same example, find all sailors with a rating above 7. Now, here what I am doing is I am specifying what should be the domain of these variables. What are these variables? This is a sailor, for example, in the sailor example, S, N, R, A, that is what this stands for. S is sailor ID, N is his name, R is the rating, A is the age. These are the 4 attributes of that particular relation whose value or whose domain is fixed. Okay. So, what it says, these are variables whose domain is fixed, belongs to the sailor relationship, and I am specifying this this variable or attribute should have a value greater than 7. So, when you say this, it means find me the column values of S, N, R and A, where S is an integer. This is specified in my definition of this relation. This says S is a integer, this is a whatever. So, that N is a string, because we are talking about domain relational calculus. R is an integer, A is a floating point number, such that S, N, R, A is a tuple in the sailors relationship and the value of R is greater than 7. So, this all this is told in domain relational calculus. Now, let us go back to tuple relational calculus. So, we have just seen an example directly, this is the example we saw. Now, let us go a little more in detail about the formal way in which this has been. I hope you have understood intuitively what this means. Now, let us go formally into it. So, the query is of a form T, a predicate containing T. So, T is a tuple, okay, and I will get all tuples which for which this predicate is true. So, T is a tuple and P of T denotes a formula in which tuple variable T appears, and the answer, that is a query, and the answer says get me the set of all tuples T for which this predicate or formula P of T evaluates to true. That is the meaning of that particular. So, what, for example, if I take this means find me I am defining all tuples and this is a formula that I have, and the answer is find me all tuples that satisfy this particular. So, a formula can be defined in this way. It can be atomic formulas, get tuples from relations or compare values, or formulas can be built from other formulas using logical operator. This is true for any expression that you talk about, whether it is arithmetic or logical. So, now here I am saying in general tuple relational calculus query is of the form T given predicate. This is tuples given the predicate. If this is true, I will get the value of all the tuples. The answer to such a query is a set of all tuples T for which this is true. So, an atomic formula, we said that it consists of 2, atomic formula and this formula. So, an atomic formula is one of the following: R belongs to rel, this is a typical formula, this is that actually this is no, I will not talk about project operation. Let us just say that R is all the tuples, I mean I am talking about tuples that belong to this relation, and then I am saying that I can have any type of expression or formula as it is called R dot A op S dot B or R dot A op constant, where this operation that we are talking about can be less than, greater than, equal to, less than or equal to, greater than or equal to, not equal to, and so on. So, these are all these operations. And in addition, you can have a formula which can be an atomic formula where P and Q are formulas. So, these are the comparison operations, these are the logical operations. So, this is a not P, this is a not P, this is P and Q, both these have to be true, one of this is true, this is if this is true, then P is not true, and so on. And you can also have the quantifier here, there X is a tuple for which this predicate is true, I mean yeah, and this is all tuples for which this predicate is true. Now, up to now we have looked at what are the basic components of a tuple relational calculus. It consists of a tuple and a predicate or a formula, and the formula consists of an atomic formula with comparison operations or a logical formula formed between two atomic variables, and the Boolean expressions are called well formed formulas or WFFs. Every reference to a range variable is either free or bound within a context. Now, we were discussing about tuple relational calculus and the well formed formulas. So, we are going to talk about free and bound variables. Now, every reference to a range variable, that is what we get in that expression, the well formed formula, can be free or bound. Now, a bound reference can be replaced by a reference to some other variable without changing the meaning of the expression, and a free reference is not so free. Okay. So, the use of quantifiers, if you use the quantifiers for all x or their x is an x, which we have discussed a little bit before in a formula, then we say that x has been bound or it is binding x. A formula, a variable that is not bound is said to be free. So, there is an important restriction that if, remember, this is the format of the query, given a tuple, I mean t, p of t. In this expression, the variable t that appears in the left of this this symbol, which essentially says that tuples that satisfy this particular predicate, this particular value t must be the only free variable in p of t. In other words, all other tuple variables that do not come on that left hand, which we do not want the answer about, must be bound. So, I will repeat this again. So, if you have t, all tuples that satisfy this predicate, then whatever tuples you have here or whatever variables you have here, these variables have to be, they must be the only free variable in the formula. All other variables which are not coming in that part should be bound. So, now let us go a little more in detail about this for all. Remember, this is a quantifier, it is also called as universal quantifier. So, for all x, p of x is only true if p of x is true for every x in the universe. Now, as far as the database is concerned, the universe means in whatever tuples are there in that particular relation. So, for all x, p of x means this p of x is true only if it is true for all x, every x in the universe. So, for example, if I say for all x, x dot color is equal to red, it means that whatever x is, we are not telling what is x. So, whatever x is, everything that exists is red. But this cannot, we cannot say, we have no thing of saying that everything that exists in the world is red. So, here what we can say is for all x, x belongs to boards. What is the meaning of this? X is a member of boards. This is boards is a relation, x is a variable or a attribute of that particular boards relation. Implies, I will come to implies a little bit later, x dot color is equal to red. Now, what is this trying to tell you? This is a logical implication. We will go a little more in detail about this. It means that if A implies B means if A is true, B must be true, and is the same as not A or B. This is a digital part of our explanation. So, what is, let us go back here. It says that if x is an attribute of the boards relation and you have tuples corresponding to that boards relation, then all the tuples of boards color will be equal to red. So, let us go a little bit in detail about these quantifiers. So, as I already told you, quantifiers for all, that is this symbol, is called as universal quantifier, and it just says that for all values of v, p is true, and this is also called as iterated and it is will evaluate true as long as all are true. Okay. Now, the next quantifier is axis. This says that axis is an, it is called as existential quantifier. So, we have two quantifiers, universal quantifier and existential quantifier. So, this says that x is at least one value of v for which this particular predicate p is true. Formally, this is an iterated OR. So, false or p t1 or and so on, where we will evaluate to false if m is equal to 0. So, now just to go back to this implies, what is the meaning of implies? I will just give it a little bit in detail. So, you have two variables a and b and you are saying that a implies b. Okay. Now, if a is true, b must be true. Okay. So, you have b being true. Next, if a is false, okay, if A is true and B is false, if A is true, I will just go back again. If A is true and B is true, then the value of the implies is true. If A is true and B is false, then that means it does not imply A is B. That is, if A is true also, B is becoming false. So, the value of the implies is false. If A is true and B is false, the expression evaluates to false. What are we essentially saying? If I have a value of A, that value implies a value of B. So, if A is true, B is true, then the implies has a true value. If A is true and B is false, it contradicts that. So, you have F. Now, if A is false, then we are actually not bothered about what is B. So, it can be true. If A is false, it can be true. So, if A is not true, we do not care about what the value of B is. So, the expression can be made true. So, this is the truth table. What does it say? A true, B true, true, A true, B false, false, A false, B true, it can be anything. So, true, A false, B false also it can be true. It says that for all x, x belongs to yes, x is a member of boards. What does this mean? For all tuples where the tuples belong to the boards relation, that particular tuples, this attribute's value is equal to red. So, for every x in the boards relation, the color, that is another attribute, has to be red. So, this can also be written as for all x belonging to boards, x dot color is equal to red. So, now let us look at existential quantifier. So, this says that for all, this is the same thing, but what this says is for there exists an x where x belongs to the boards relation and x dot color equal to red. This says that x is a tuple x in the boards relation, that at least one tuple will have its color equal to red. So, it can also be written as there exists an x belonging to boards where x dot color is equal to red. Now, the difference between these two is this says that all the tuples belonging to the boards relation, the color of that, if the color is an attribute, it has to be red. This says that there should at least be one tuple in the boards relation whose color is red. So, in the tuple relation calculus, the variables range over tuples rather than field values. For example, the query find all sailors with rating above 7, which we have already seen, is represented like this. Now, what is projection? Find names and ages of sailors with rating above 8. Now, suppose I want to do this, then what I do is, this is S, I want to find the tuples, there exists an S1. Please note, remember we told that the only variable that can be free, okay, only variable that can be free. What is the meaning of free and bound? Free is one which comes without quantifiers, and if it comes with quantifiers, it is called bound. So, that is what we have said. And then another rule that we said is that if you have variables in your expression, variables that are to be determined can be free, others have to be bound. These are two conditions we said. So, now if you to look here, it says that, I will first explain this, this says that find me all tuples, okay, and there exists an S1 belonging to sailors and S1's rating is greater than 8, then I am trying to find the tuples. This is the projection part. So, S dot S name, I want to find the names, is nothing but S1 dot name where my rating is greater than 8, and S dot age is equal to S1 dot age. So, S1 is sailors. Now, S is not bound, S1 has to be bound. So, S is a tuple variable with two fields, and so this is a projection from Taylor's. So, this will be a tuple variable having names and ages. So, if you take this example, so 9 and 10. So, I will get the Yuppie 35 and Rusty 35 as my output. Okay, so this is S1, this is my S. Now, this is the first one. So, that satisfies that rating. So, I get this, and this does not satisfy, this does not satisfy the rating, this satisfies. So, that output also will come. So, this is my S, this is the tuple I want. Okay. So, that is how projection and selection are understood from the tuple relational viewpoint. Now, let us look at joins. Find sailors rating, joins means two tables. So, find sailors whose rated greater than 7 who have reserved a boat number 103. This is the boat relation and this is the sailors relation. So, S is a tuples, S belongs to sailors and rating is greater than 7 and their X is an R where R belongs to reserves. This is a reserves relation, not boat relation. R belongs to reserves and R dot SID, okay, R dot SID equal to S dot SID. So, these two we are joining together with this relation and we have got another condition, R bid is equal to 103. This essentially says find me all tuples belonging to the sailors relationship, okay, whose rating is greater than 7 and who have their X is an R belonging to reserves where R dot SID is equal to S dot SID from this and in addition they should have only reserved boat 103. So, that is what this is saying. So, this is a joint relation. So, you take S and find the rating greater than 7. So, it finds this and then you find out whether this SID exists here, does not exist, only this exists, but that rating is not 7. So, I come here, I find out this, now I come here, now the rating is greater than 7, but and I have 58 and he has booked 103. So, okay, so I get the answer as 58, 103 and this in the reserves. So, this is the, what does this say? Find sailors rated greater than 7 who are reserved a red boat. So, this is again the same part. Here I am using 3 relation, reserves and boats description also. So, I am saying that get me sailors who is greater than 7 who have reserved a boat, okay. So, this is who have reserved a boat and then there exists a boat, this boat whose color is red. So, these are quantifiers. So, you can look at some more examples and find out what it actually says. This says find the names of sailors who have reserved at least 2 boats and the query is said to be safe if you have decided these things. Now, fortunately we can define a restricted syntactic class of queries which are guaranteed to be safe and safe queries can be encoded in relational algebra. So, you should now understand that relational calculus consists of tuple relational calculus and domain relational calculus and we have looked at only basically relational tuple and we also have to look at domain. So, we have discussed already it ranges over domain values not tuple values. So, if you look here find the names of all managers who earn more than 25. The thinking process is the same, but what we have here is we also tell all the domain values that can be taken by these particular variables. So, the queries will now be of the form x1 to xn all the attributes and a formula consisting of x1 to x1. So, x1 to xn are the domain variables and f is a formula with the free variables x1 to xn. Remember free and bound is same meaning. So, find all sailors with rating greater than 7. We have already discussed this example when I was initially talking about domain relational calculus. You must be able to understand it a little better. Let us take, so this is a simple projection where I am projecting only the value of RA, that is only R and A, and this is along with that I am also putting some condition. So, the formula is like this x1 xn belonging to the relation and xi is a binary operator. So, you can have these binary operators. The formula will be these parts of the domain relational calculus are similar. I have just written it for completeness sake. So, find the names of sailors rated greater than 7 who have reserved a boat 103. So, please note here how all these are bound to sailors, that is the and I want to get n. So, that is the free variable, but this part of it is not free and I am using all these. So, this is the explanation of the same query using domain relational. I have just given all those that we have done in the previous one itself. Okay. So, you can try out some examples and understand this, and this query by example is the language that has implemented domain relational calculus and a condition box is used to allow all complex conditions. So, there are again unsafe query problem. So, there exists correct calculus queries that have an infinite number of answers. So, these are called as unsafe queries And as far as the expressive power is concerned, there are theorems that say that you can every query that can be expressed in relational algebra can also be expressed in TRC. So, this is the relational completeness which you have already discussed. So, the relational model has rigorously defined query languages that are simple and powerful. One is a procedural language, relational algebra, the other is a declarative language, calculus, and relational algebra is more operational, as we already told, and the relational calculus is more declarative, and almost every query can be expressed in both the ways, even logically differently as well as expressiveness differently. So, in this lecture we have spoken about relational algebra and relational differences between relational algebra and relational calculus, and we have querying using tuple relational. Actually, basically we have done tuple relational calculus and left understanding of domain relational calculus and as basically an example for you. And some exercises you should do: give the differences between relational algebra and relational calculus, give the differences between tuple relational calculus and domain relational calculus, explain what is meant by free and bound variables, what is quantification, there are two types of quantification, so explain them. Then what I have done is I have given you an example database, employee database, and I asked you to find out write expressions in both the tuple relational calculus and domain relational calculus. This is left as an exercise for you to do to understand this concept. So, thank you.